All right, this last problem is going to seem a bit ridiculous, but there are problems that are going to come at you in this way. So remember, you're going to get these as word problems. I'm kind of going over them and showing you little diagrams, but you're going to get them as words. So what I would like you to consider is to, number one, of course, these were left over from last one, so let's get rid of these. I'd like you to consider, of course, reading the word problem and listing the variables. I would like you to consider that. But I'd also really encourage you to draw a little sketch of the information that you have and place the information in the correct spots. Because you could read a problem where it says, well, you know, a car had slowed down to 10 meters per second when it was decelerating with at 5 meters per second squared, and even though they gave you that 10 meters per second, by the way, that should be fixed. Even though they gave you that 10 meters per second in the very beginning of the problem, that was a final velocity that they told you. So keep that in mind. So be careful and visualize the problem. If you cannot find the given information and cannot visualize what's physically happening, it's going to be very difficult for you to solve problems. In this example, yeah, I have a car traveling in the negative direction. You're going to read problems and they're going to say, all right, everything's traveling in the negative direction. And you're going to have to remember that and use it. I have a problem traveling in the negative direction. It has a final speed, and the problem may say speed, not velocity, so we're going to have to deal with that. Speed, 10 meters per second, negative direction. Started off with an initial speed in the negative direction, slowed down, or sped up. We'll have to decide, we'll check it out. And went an additional 30 meters for displacement in the negative direction. What was the initial speed when this happened? Well, the problem will have to say, was this speeding up or slowing down? Because right now we wouldn't be able to solve for it either way. Because with the information, we don't know, did it speed up or did it slow down? So we're going to say in this problem that we slowed down. We slowed down. So this is going to create some issues because if you look at the formulas, we only have velocity final, we have delta x, we have acceleration, and we're looking for velocity 1. And the only formula that matches that is this one here, the bottom one. So v2 equals v1, both of those squared, plus 2a delta x. Now, I'm going to get real obnoxious here with the signs. This problem said that we are looking for v1. I'm telling you the problem said it. I'm making up these problems as to present. So I'm telling you we want v2. I'm also telling you that we're slowing down during this problem. So in the words it would say that it is slowing down. It is reducing speed. But here's the problem. This problem was defined as moving in the negative direction. This problem would be easy to solve if it were moving in the positive direction. And some of you may figure out, well, if everything is moving in the negative direction, can I just flip all the signs and make it move in the quote-unquote positive direction? And that's possible, but let's stick with what we were given. So, I'm traveling in the negative direction, trying to find v1. Let's plug in what I do have. Well, I know v2. Now, I did write 10 meters a second up here, but that was its speed. But it's traveling in the negative direction because I said it's traveling in the negative direction. So this is really a negative 10. But I know I didn't write a negative 10 there, but it's indicated in the reference frame. And that negative must be there. But Tapper, I squared, I don't need, no, that negative must be there. I'm looking for v1 squared plus 2 acceleration. Now, the problem is going to say you're going to have a deceleration, or you're slowing down with an acceleration of 5 meters a second. Now, if you're slowing down with an acceleration of 5 meters a second, well, if you were moving positively, that'd be a negative 5. But I'm not moving positively. I'm moving negatively, yet I'm slowing down. So you have to remember from the previous discussions that slowing down in the negative direction is really a positive acceleration. That sign is important, because if you don't get that sign right here, you're not going to get the math right. It's going to break down the formula. So if you're slowing down in the negative direction, you actually have a positive acceleration. It's kind of like a double negative. Right? If I'm speeding up in the negative direction, I have a negative acceleration. If I'm slowing down in a negative direction, I have a positive acceleration. And then to really hit this home, I did travel 30 meters. But again, in the negative direction. And so that must be a negative displacement. Is this problem ridiculous because I should have called this all positive and it would have made all this sign play a lot easier? Yes, I should have. But you might not get problems like that. Now, if I do the sign play correctly, everything should work out. This ends up being 100. And this ends up being 300. Actually, minus 300, because 2 times 5 is 10, 30, 300, negative sign. Right? Now, if I take this to the other side, rearrange a little bit, I will tell you these formulas are smart. If you ever are doing any of these formulas, because you got squares here and squares here, if you're doing these formulas and end up trying to square root, because you got to solve, you got to take a square root here. If you're ever taking a square root and you're trying to take the square root of a negative number, you did something wrong. Again, these formulas are smart. If you ever end up trying to take a square root of a negative, go double check your signs. Right? Remember, if I would have had this as a positive 30, this would have went plus, and this would have ended up being negative 200. I can't take the square root of a negative. This is physics. It must physically be possible. I cannot work with the imaginary realm. So we have to make sure that this is correct. Now, if I take the square root of that 400, I get 20. But to really mess with you, remember when you take the square root, you get 2 possible solutions. You have plus and minus. Yes, this would be in meters per second. And so you're like, oh, what? Now you have to ask yourself which solution matches the physical scenario. Well, the problem originally said that you were moving in the negative direction. So when you get this, not V2 by the way, I'm sorry, I should have fixed this earlier, sorry about that. When you got this solution for the initial speed, and it said you were moving in the negative direction, you must pick the negative answer. So again, this is physics. This actually represents physical happenings, and the math must match reality.